Wednesday class. So I'm going to try to get it into the FTP site just as quick as I can. And this is, as I promised, the survey exercise we're going to do. I found a survey online of some work that another surveyor had done, and I thought it would be a good exercise to duplicate this survey lot, which is an 18.35 acre parcel of land. And this you may find valuable when you get into more of your surveying classes. It has two components, main components. It has a written description of the lot from the surveyor, and it also has the drawing which emulates the same dimensions in it. What we're going to use, it has record distance and angle, and it also has the actual. We're going to use the actual to lay this out. So I'm going to go back to the written description, and if you do this yourself outside the classroom, you probably want to print this information out. I will have it up on the first class site. So we're going to, this is kind of fun because, to me anyway, of course I'm weird, but it's kind of fun because it's closing the chain. In other words, parcel of land needs to end where it started in order to be totally enclosed. So if you're off by quite a bit at the end, then obviously there's either something wrong with the survey or there is a problem with the way you entered the information. So let's go ahead and give this a shot. I'll keep this in the background, but I'm going to go ahead and open up our 11 by 17 Civil version 1 drawing from our seed files. And the first thing we'll do is a file, once this is open, to a file, save as, and we're going to call it, I don't remember what assignment we're up to, we'll just call it property map 1. And that, of course, just makes a duplicate of our existing 11 by 17 property map. So we'll go to our settings, design file, working units, and we're going to take a look at our working units are in feet and inches to 2 decimal places. Actually, format is just master units, so we're just going to work in feet to 2 decimal places, which works fine. Then I want you to go to the angle readout. Under the angle readout, you can see our format up here is in degrees to accuracy of 2 decimal places. We'll change it to 2 decimal places, but we're going to change it now to degrees, minutes, and seconds. Within the compass there are 360 degrees. Within each minute there are 60 minutes to a degree and 60 seconds to a minute. So this is how we're going to read it out, is in degrees, minutes, and seconds. But rather than the azimuth mode, we're going to use bearing mode, which gives us direction north, south, east, and west. So many degrees, so many minutes, so many seconds to 2 decimal places. And we're just going to say OK and do a Control F to save the settings. The map itself, if we go back and take a look at it, has some interesting information on it. Let's see if I can zoom in on this particular area. Abbreviations. Point of commencement. This is where they started the survey. Point of beginning is where the actual property started. You can see CT is a crimp top iron pipe. OT is an open top iron pipe. And CR is a 1/2 inch capped rebar iron found. And then there's some fences. There's also some flood zone. So whenever we see these initials on the map, if we look up here, there's a OT, which we determined was open top iron pipe. In other words, somebody just drove a piece of 1.5 inch galvanized pipe. There's some cap pipe over here. There's some CT, which was crimped iron pipe found. So we know what all of these kind of mean. If we move over to the left, we see there's a flood zone area. There's some sanitary sewer pipe that runs through here with some manholes, and it gives us some dimensions. So we can see here, for instance, the angle that the line is moving in a bearing mode. It's going in this bearing, this number of feet, 1019.19 is the actual. So, and there's our point of commencement, which is up here. This is where they started, and they see they went north-south. So north straight up is 0, 0. in the angle 325 feet on the base. So we're going to start up here and go down 425 feet on the drawing. So we just go back to our property map drawing. Let's create we'll go to our primary level to start with, color white. I'll use a 2 so it shows up well on your screen here. And we're just going to start with a smart line. There we go. Just left click anywhere. Pull it straight down, and it says that commencing at the northwest corner of the half of the southeast quarter of Section 4, Township 6, Range 2, West Mobile County, Alabama, thence running south a distance of 425 feet. Well, 425 feet running south is going to go straight down, so just type in 425 and left click. I'll just pan over here. So the point at the bottom is our point of the start of the property line. And it says here that at the bottom of that 420 feet, it's going to run a distance of 1,019.19 feet. So I'm just going to left click here, and we type in for distance. You can see in the AccuDraw mode we're in distance angle. So 1019.19. Hit your tab key, puts you down in distance into the angle mode. And this is the angle is north. Just type N 86 for degrees. Hit your semicolon, which without hitting the shift key, and it gives you the degree symbol because we're in this bearing mode. And then we're going to type in 17 degrees or 86 degrees, 17 minutes, and then you're going to hit shift colon, which is going to differentiate between the minutes and seconds. 23 seconds even, and then hit E for east. You can see when I hit the E, it automatically bumps the line up, and it locks me right there. So again, it's N 86 semicolon 17 colon 23 E. Left click and then right click. We're going to do this. Each line is started separately so that it doesn't rotate the compass. So that's our first point on the property line. Then it says it's going to run a distance of 345.25 feet. So we'll go ahead and start our smart line here. Hit our tab key to bump it up into the distance mode. And we said that was 345.25. Hit our tab key. Now we're in distance. In the angle, or the bearing, is going to be north 86 degrees, 86 semicolon, 28 colon 05 seconds east. Not much of a bump, but enough. And then just left click and right click. We've created 3 lines here. I'm reading this off the chart, and I'm going to kind of cross these out as I go through them. The next one, start a new line again. We'll start with the bearing first, because we're already in there. This one is north 68 degrees, 10 minutes, 50 seconds east. Takes quite a bump. We'll hit our tab key, and the distance on this one is 730.63 feet. Okay? Cross that one out. Thence, they use the word T-H-E-N-C-E, thence it's going to run, got a crease in my paper so I can make sure I'm reading it right. North, 56 degrees. This is just a short one, but we'll go ahead with our smart line. You can see I'm already in distance. So this one's only 32.72 feet. Hit our tab key. And this one is going to be north, 56 degrees, 25 minutes. Whoops, I put 35. 25 minutes, 08 seconds east. Left click and right click. Next, we're going to run from this point north 56 degrees, oops, I skipped one, sorry, I'm going to go back here. I'm going to go south 31 degrees, 15 minutes, 36 seconds east. Tab, and the distance on this is 140.08. Then we go down. It's going to be, we're already in distance, so the distance on the next one is going to be 240 feet. We key that in first, tab. Now we're going north, 56 degrees, 11 minutes, 54 seconds east. That was 240 feet, okay. They got a right of way on this road. So from here it's going to run. We'll hit a bearing angle in there first. It's going to be south 34 degrees, 44 minutes, 29 seconds east. Tab, and the distance is 219.7 feet. Left click and right click. From there we're going to run a distance of 1,191 feet, or 0.6, let me just make sure it's 0.67 feet. This one is going to be at a distance of south 65 degrees, 52 minutes, 47 seconds west. Right click. Okay. Next, start from this point. We're already in distance. We're going to put in our distance of south 88 degrees, 09 minutes, 57 seconds west. Tab, and this one is a distance of 1371.22. Left click. And it's going to go up a distance of 325 feet. So this survey is actually off a little bit. It says it's only 320 feet here, but obviously they missed some stuff here somewhere, because I'm pretty sure we've got the numbers in here right. It's not actually true north, so we we brought this line straight down, you'd see we have a distance of about 6 feet that we're off. It's a pretty big piece of property, so we're just going to close this off here at this point and just label it out. It may not be a good survey. I've got some other examples that we can look at. We'll just trim this out as soon as I get my toolbox back. There we go. It was off by about 6 feet. We'll delete this line here. So here's our shape of our property. And what I want to do is create this as a shape. So we're going to take our 6 3 tool, create complex shape, set it to automatic. Then you can just left click on one of these lines, let it float all the way around until it all turns this fuchsia color, and just left click again. The reason I did that is I want to check the area. If you look under your D toolbox, you'll see an area measurement. And in square feet, we can see it's 794,318.983 square feet. We can change this to acres. We'll use US survey acres, and when we check this again, we'll see it's 18.235. I believe our drawing said it was supposed to be 18.35, so we found about 1/10 of an acre off here on this survey. I'm not sure exactly where it's coming from. The shape looks correct. It just appears that somewhere between the actual and the record, there's some differences here, so we made up the difference on this line. So there's our property, and before we actually start dimensioning this piece of property, let's go to our sheet file, sheet 1. Remember, this is an 11 by 17 sheet of paper. We're going to reference that map in here. We know that going back to the primary model, wherever you drew it, let's measure a distance from here to about here is 2,500 feet. Now we got 17, so let's try about a 1 in 400 scale on this sheet file just to see what happens. Go to our reference tool. We're going to attach this project. Property map 1. We want our primary model, say standard top, and let's go to 1 inch equals 400 feet. Actually, I think we said 300. Let's try 1 inch equals 300 feet. Hit OK. Over here, just left click. Yeah, probably go a little bit bigger. So we'll just change this now to 1 inch equals 200 feet. So now we have the property on here at 1 inch equals 200 feet. Before we forget that, let's get it on the paper correctly. We'll go down here and actually write in that scale. So where I've got date, I'm going to change that to scale. 1 inch equals 200 feet. So now we have the proper scale on it. Let's start looking at some of these. One of the items on the map, if you've printed it out, I printed it out. Point of beginning was a open top iron pipe right here on this corner. So I'm just going to draw a little circle in green. .01. That's small enough, and we'll label that when we're ready. What we want to do is put the distance and the dimension on the same angle as the line itself. let's just take a look at some of our angles. If I can measure, we could do an angle between lines, but I don't think any of these things would give us, it's not what we're looking for. So we know by the written description is what we need to put on here. We'll add a north arrow later on. But what we need to do is put some text on here. Style will be 07 center justified, so it's going to be red. And instead of the method saying by origin, I want you to say above element. We're going to type in this first one, which is north 86. Use the caret symbol. It's right up above your number 6 on your keyboard. 17 minutes, use the foot mark. 23 seconds, use the inch mark. East, couple of spaces, 1000.19.19. Now if I just left click on this line, doesn't look like that font picks up the degree symbol. Let's go take a look at this. My machine is, maybe it's the font we're using, so we'll change this to engineering. Let's see. So when we change it to an engineering font, it gives us that degree symbol. And the other thing we want to take a look at is the spacing. See if we can do it here. Spacing. 1, and save. Let's do a little test here. That brings it up a little higher on the line, so we'll try 0.5 instead of 0.05. Hit save. That's better. So we can kind of pull this. We don't need to retype it. We'll just pull it up a little ways. And that's how we want to mark these with, and actually I want to probably say put the feet mark here at the end for the distance. Go to the next one. We know that this one is actual north. We're going to go to our dimension. It's going to be north 86 degrees. And again, you're going to use the caret symbol. 28 minutes, 05 seconds east. Couple of spaces. I'm going to put in a distance of 345.25 foot mark. If we just left click on this line now, you can see that it pops it right into position right along the line. Now this next one is going to be a little more difficult. We'll use this as a place note tool. So we go to the, in this one we're going to say north. Oops, I got the wrong one on here. Bear with me a second, I missed the line. There we go. That one belonged down here. They do say there's a CR. CR is a 1/2 inch capped rebar. So if we come over to our, I'm just going to copy this circle. Hold it. can see where this pin is going to be located, north 86 degrees, 28 minutes, 5 seconds. And then this one is actually going to be north 68 degrees, 10 minutes, 50 seconds east, 730.63. Now we're going to place our note. This one is going to be north 56 degrees, 25 minutes, 08 seconds east, 32.72 feet. What we'll do is just point right at this little stubby wall. Want to be in dimension level. Place that one right out there. So we're putting our angle, our bearing angle, and our dimension. Excuse me. Alright. Let's do the same thing with this other one with the arrow tool, because we got kind of a short distance there. This one is south 31 degrees, looks like 15 minutes, 36 seconds east, 140.08 feet. Put that one right in there. Back to our just place text tool. So we can put this one on the line. This one is north 56 degrees, 11 minutes, 54 seconds east. And what we'll do is put the bearing angle on the top. We'll change it to below element. We're going to type in the distance here at 240.0 feet. Left click on the same line, it's going to place it on the bottom of the line. So you can do it kind of either way. Whatever provides you the best room. Alright, next we've got the roadway, which is south 32 degrees, 44 minutes, 29 seconds east. Put that one above the element. And then below the element, we'll put the distance at 219.70 feet. Pop that right in there. A couple more here. We'll go just above the element now. This one is south 65 degrees, 52 minutes, 47 seconds west, 1191.67 feet. Pop that right in there. Come over here on this side. And this one is going to be south 88 degrees, 09 minutes, 57 seconds west, a couple of spaces, 1,371.22 feet. Place that one there. Lastly, we've got north 325.00 feet. I placed it below, so let's it below the line. There, it's kind of rotated. 180. Yeah, I think on this one we'll just rotate it by hand 180 degrees, so it reads right. So 2 points, rotation, swing it around. Probably place this on top of another text one too many times. Next thing we're going to do is change the line style of that border. Not necessarily the color, but the style we want to put in as a kind of a border line. So we use this number 6 line style, and just left click. Oops, we got to go back to our primary model. Line style 6, and go back to the sheet view. That places that all right level. Using the same technique. One vertical line right here that went straight up. I guess I got to do this in the primary model also to get the right distance on it. So that was a point of start, or POC, was 425. So now we can go back to the sheet. What I want to do is grab that green circle again. I'm sure I got 2 there, but now we'll just use our copy tool. We select it first and then use copy. And start placing these pin locations on the property. Any place there was a change in direction would have some kind of a pin or a marker. I think we already have one right here. So then starting over on the left side, I can see from the map we have an OT. Period T period. Change back to red. No. Same on the bottom. O period, T period. At this intersection. We have an old OT right here on this one. So we say O period T period parentheses old. Move up. This one is a CT, C period T period, which is a capped. I'm sorry, that was OT. Misread it. CR is this one. C period R period for capped rebar. Another capped rebar down in this corner. Capped rebar this corner and this corner. We haven't it said IS, but I'm not sure what that is, so here. this one. You don't have to put them in exactly the same spot. And I should take care of it. And up here at the top we have P period O period C period, point of commencement, is where they started their survey from a known point, and then they came down to this pin, which is the PO point of beginning, so POB will be located here. So P period O period B period. Right there. Okay. We measured this 18.25 acres, so we're just going to put a note in here. It's going to say 0.25 acres. Oops, below element. I want it by origin, sorry. There we go. I still had it on above element or below element, so 18.25 acres. We've got a, right along this line, we've got a sewer line running through here. So we want to kind of locate that as part of this exercise. Let's just go back to our primary model. We're going to put a couple construction lines in here in green. So if I start right here at this point, and I'm going to type in a distance of 394.4 feet at an angle of north 86 degrees 17:23 seconds east, and down here at the bottom we're going to have a distance of like 443.3 feet. Hit tab. 443.3, tab, and this one's going to be south 88 degrees 09 minutes 57 seconds west. And we can actually show these lines now. We'll show them as a number 3 line. Just take your smart line, find that point and that point. You can actually extend these lines then through the openings and delete these old temporary lines. So there's our sewer line. We'll go back to our sheet file now. We can just locate that as, we'll just put a note on this one, we don't need to be, I'm just going to say sanitary sewer line and manholes on our note tool, so we're just going to place the note right there. The last thing we'll put on this particular exercise, there's quite a bit of information we could put in here, but this is just a basic survey. Let's put in a north arrow. Sometimes we can do this with cells. If I go to settings or element cells, file, attach, and look for a cell library, I may or may not find one right off the bat. So we'll just draw one in for now. We'll get into some cell libraries later on. So for now, we'll just put this in the construction level in green. I just want to draw an arrow straight up with a nice flag on the end of it so they know which way we're going. And we'll just type in north some type of a north arrow on the drawing. Over here, we'll edit this and say survey drawing, plan, delete this bottom, just kind of move this. So as far as dimensioning goes, we have our dimensions on the lines themselves, which indicate where it's at, and I should have been more careful about picking one up that was more accurate, but you kind of get the idea of how these survey lines are put in. We may do another one a little bit later on. I've got another example that I know is more accurate. We'll say 10, 13, 9. This will be survey assignment 1. Bearing angles. And distances. Perfect. 1 inch equals 200 feet. And we'll go ahead and do a print on this, Control P. Not sure if I have my utilities, but we're going to add our select Bentley driver. Let's see if I have it here. I may not have pulled it over. Actually, I think I have it on my mobile disk. I'm using a different computer right now. Utilities, there's my printer. We're going to go to pen table, attach, same location. Utilities, there's my pens. Everything goes to black and white. We're seeing here that the sheet is a B size cut, 17 by 11, 1:1 is the paper size, full scale. We hit print. We're going to put this right in our, in your case, your homework directory. Again, I'm using a different computer, so I'll just place it here. And it's going to be called property map 1 or property map, your initials. Hit save. And I will put that folder in the homework directory of first class when you're ready to put that in place. And that should cover it. So that's your first assignment using bearing angles and distances. I can come down here and take a look at it. Oops, that's the other one. We can go to File, Open. Go to directory I saved it in. Property map 1, just want to take a look, kind of zoom in, take a look at our line weights. Everything looks pretty good. I think if I had it to do over, I'd probably mark myself off for having this text run across the survey line. So I'd probably go back, take a few minutes, come back here, and make sure that I move this text over a bit. So none of that information is crossing. It just takes a few seconds, reprint it, see if there's anything else that's kind of muddling it up, and that all looks good, so I just reprint this again. But the survey property map, I immediately picked up on the fact that this text was running across the sewer line. You see I have my note up there, so that pretty much covers this assignment. So let's get that done, get it put in, and it should be in good shape. Come up with some new stuff for next week. I'll want to go over chapter 6 on the video, and I may talk about